Assalamu alaikum respected students. We are again here with a new topic, the fundamental rule for choosing the acid base indicators. What are the fundamental rules for choosing the acid base indicator? In last videos we have discussed about the titrations, acid base titration and types of acid base titration. In this lecture we will discuss choosing of acid base indicators and titration curves. Basically, choosing of acid base indicator depends upon the pH transition range. pH transition range is that range in which color change intervals are shown. That falls within the steepest and most vertical section of the titration curve. The steepest and most vertical section of titration curve is that one. That is the steepest and most vertical part of the titration curve. Okay, hope so you understand this point. What is the vertical and steepest point? This steep region surrounds the equivalence point. Basically, last video we have discussed about the equivalence point. This steep region surrounds the equivalence point because the equivalence point fall in this steepest region, ensuring that indicator color change, that's the end point, because that after the equivalence point end point is appeared at with the color changes only observed, which show that reaction have been completed and stop your titration. Occur within the addition of minimum amount of titration, making very close. We have already discussed the setup of the titration, in which the burette is filled with a standard solution that is also known as titrant, and that's the aluminum flask or titrate flask, in which sample or analyte with the indicator is taken, and drop wise standard solution is added in this in the sample solutions with the constant shaking. Drop by drop we add the standard solution after a specific point, suddenly color change. That is the end point. Before this end point is the equivalence point. Basically, equivalence point is the theoretical point where the moles of titrant exactly equal to the moles of analyte. That this pH is determined by its salt formation, because equivalence point in acid base titration, basically neutralization point. At this point, equal amount of the titrant, that's the acid, that may be acid or base, exactly titrated or reacted with the acid or bases. No extra is acid in the aluminum flask, no more base is present in aluminum flask. That is the equivalence point. After reaching this equivalence point, end point is appeared. That's the experimental point, when we add one extra drop of acid or base, which show that the sudden color change of the solution. The suitable indicator is chosen to make the end point occur as close as possible to the equivalence point, minimizing the titration error. The selection of suitable indicators is very, very important. Basically, what are the indicators? Indicators are represented by H, I and mean indicators. Basically, indicators are weak acids, sometimes weak bases, that change the color when the ratio of its conjugate acid to its conjugate base change significantly. We take the example of indicators that are very well known indicators, as the phenolphthalein. Phenolphthalein basically is a weak acid. Being a weak acid, it shows no color in acidic solution, colorless in the acidic solutions. When pH cross the 8, around about 8.3, it suddenly show its pink color. It means its conjugate base is colored, but its conjugate base appeared pink in basic media, and its acidic form is colorless in acidic media. Okay, indicator colors change range is approximately plus minus 1 with the pKa of indicators. Therefore, indicator considered of ideal for its pKa values. The pKa values, that's the negative log of K, ionization constant, is numerically close to the pH of equivalent point. This pH is equivalent point close to the indicators pK values, plus minus 1. Okay, see that these are the 4 titration curves of 4 types of acid base indicator: strong acid and strong base titration curve, strong acid and weak base titration curve, that is the weak acid and weak base titration curve, and weak base and strong base titration curve. Basically, their equivalent points are very important for the selection of the indicators. In the strong acid and strong base, equivalence point is equal to 7. Equivalence point, that's equal to 7. That is the point, equivalence point in strong acid and strong base. In strong acid and strong weak base, equivalence point is less than 7, and in case of weak acid and strong base, equivalence point is around about greater than 7, and in weak acid and weak base there is no specific equivalent point, pH point, no pH equivalent point, it may be varies. So for these cases in which weak acid and weak bases are involved, no specific indicators is applied. For this case, only pH meter is suitable for the weak acid and weak bases. That is the selection of indicators in tabular forms for strong acid and strong bases. When pH is 7, most suitable indicators phenolphthalein and methyl orange. The range of phenolphthalein is pH 8.3 to 10, and methyl orange pH is 4.4 to 6.2. pH, because we know that selection of P indicator is depend upon the steepest point. We know that in the strong acid and strong base, steep point start from around about near to 4 and ends at 10. At this region we can select the indicators. The both indicators can be used, but most suitable in laboratory phenolphthalein is used. Mostly phenolphthalein is used in the labs. For the strong acid and weak base, where the equivalence point is less than 7 or acidic, but we select those indicators which show the color change in acidic media. That the most suitable is methyl red or methyl orange. Methyl red is 4.4 to 6.2, and methyl orange is 3.1 to 4.44. That there is the pH range that's also fall in their steep region with respect to strong acid and weak base. Strong acid and weak base, that but their steep point is very short, so selection of pH is must be careful in this case. Next is the weak acid and strong base. In weak acid and strong base, pH is range of start from 6 slightly acidic to around about 11 to 12. Its equivalence point is around about greater than 7. Its mean in this range most suitable indicator is phenolphthalein. Phenolphthalein is most suitable indicator, but in this case where the weak acid and weak base is used, no specific indicator, so use the pH meter. Okay, hope so you adopted, you cleared your all concepts related to the acid base indicators, the titration curves, and selection of the indicators depending upon the types of titrations. See that. Here in this graph 0.1 molar NaOH in titration curve is used. In this 0.1 molar NaOH, this means strong bases are used in both curves. See the titration curves and judge the selection of weak acids and as well as their indicators. We know that in strong base and strong acids, very sharp and long steep are observed. It's mean here strong acid and strong base are uses in this type of titrations, and we know that in strong acid and strong base most suitable indicators are two, methyl orange and phenolphthalein, but mostly phenolphthalein are used. If this titration curve show that this is the titration curve used when strong acid and strong base and weak acids are used. Its equivalence point is around about greater than 7. So in this case methyl red selection is not suitable, so phenolphthalein selection is suitable in this case when strong acid and strong base. See that strong acid, strong base and weak acid, pH range is greater than 7, so that phenolphthalein is most suitable indicator for this case. Hope so you understand all the concepts related to acid base titration, titration curves, selection of indicators. We will see you again in next video. Thank you very much.